Right, this is what I call a bit of a stinker of a question, to be honest. Requires just a bit of thought to start with. So solve the equation first of all. Cosec, this bit's not too bad. Cosec theta equals -4. Well, cosec is 1 over sine. So that will then give you that sine theta equals -1/4. So when we've got to make sine theta equal to -1/4, we're going to sine to -1 -1/4. Which will then give us -14, and we check the accuracy at once to 0.1, so 14.5. At that point then I draw the sine graph. Sine graph will come up here, then come down and go up again, and this is 180 and this is 360. So if we're dropping back here to get to -14.5, then moving across this line to get to all the values here and here, well, we'll then have then that theta is 180 plus 14.5 and also 360 minus 14.5, which will give us 194.5 and 345.5. That one's not too bad. What you will do in the exam is look at this next question and then slightly panic. The reason you'll do that is because it looks quite complex. You've got a cot and a cosec there. Well, the crucial thing first of all is to make all the trigonometrical parts the same. So we're going to get rid of the cot squared and make it into a cosec. The way we do that is we go back to what I call first principles of trig identities, which is this one that we all know, and we're going to make that cot. So cot is tan, but it's the opposite way around. So tan is sine over cos, so cot will be cos over sine. So if we divide everything through by sine squared x here, that will then give us our identity that we need, because this becomes 1, this becomes cot squared x, and then this becomes cosec squared x. So we can then say that cot squared x is equal to cosec squared x minus 1. So that then implies in this big equation that two lots, now instead of saying cot x, what we're going to now say is two lots of cosec squared 2x plus 30 minus 1 on that side equals 2 minus 7 cosec 2x plus 30. In terms of making this more straightforward, I'm going to let u at the moment equal 2x plus 30, just to simplify things down. At the same time, I'm going to times this bracket out, so 2 cosec squared u. This gives you minus 2, and you take another 2 over, so we're going to take this side over first, so it's plus 7 cosec x u. Cosec u, and then we're going to add, so we've added the 7 on, we're also going to take the 2 off what already is a minus 2, so that gives minus 4. That equals 0. At that point then, it's a quadratic, so I would attempt to factorise it. So you've got to think, right, okay, what times by 4 will give us 7 as a gap? And if we times 4 by 2, it's 8, and then we've got a 1 here. That'll give us what we need. So we've got a minus there and a plus there, and that then equals 0. So now I know that cosec u equals a half or minus 4. So cosec u equals a half, and I'll put here cosec u equals minus 4. So we've got to that point. Cosec again meaning sine, so this implies that sine u is then equal to 2, and also sine u is equal to minus a quarter. At this point here, you should click slightly that we can then use the previous thing that we've just worked out, because we're doing cosec minus 4 here. So at this point we can then say that 2x plus 30 is equal to 194.5 and then also 345.5. Now you haven't done this bit, so we'll then sine to the minus u, so u equals sine to the minus 1 of 2. And the good news about that is that's an error, because obviously sine only goes between 1 and minus 1. So at that point then you can sort of just cross that out. So we've got this, and then add 30 to both sides. So adding 30 will then give me 224.5, and adding 30 to the other will then give me 375.5. We're then going to divide it by 2. So divide both by 2. Now I've got the second one in my calculator already, so I'll just still put that in first. So that's a 7. And we want again this to the nearest one decimal place. So it's 187.8. Now I've made a mistake here. Just looking at this, I've realised I shouldn't be adding 30 at all, should I? You could have taken 30 from both sides. Sorry for the mistake there. We all make them. So take 30 off. Actually makes it a bit easier in terms of working that first one out. And the second one. And then this time we're going to divide by 2, which will then give us 157.8. And then the other one is 82.2 or 82.3. It should be 80, if you've carried it through it should be 82.2. So there we go on that. You then take a deep breath and then jump into part B. And part B then, describe a sequence, 2 geometrical transformations that maps the graph. Now for me, what I always do is do the translation first. There are 2 solutions to this, but the translation, now because it's inside the bracket, it's the X movement that you're looking at, and it does the opposite thing of what you expect it to do. So it's a translation of this, then it's a stretch of, again, scale factor a half. You'd expect 2, but because it's inside the bracket it does the opposite, and then say parallel to the x-axis. The other solution, you could have stretched first, so you could say stretch of scale factor a half, that again would be parallel to the x-axis. If you've done that, then your translation only needs to be half the amount, because you've already then done the stretch. Personally, every single time I'm doing the translation before the stretch, but you can do it the other way around as well.